8.1 starts with adding and subtracting polynomials. And we'll talk about what that is. So first, let's start with building blocks of expressions. A monomial is either a number or a variable or the product of, a number and a variable. And with whole number exponents, right? So that's a lot. So let's see what that is. So for example, 3 is a monomial because it's just a number, okay? A product of a number and some variables is also a monomial. So for example, 5x squared, that's a monomial, but the condition is the exponents have to be whole numbers, right? So like that one. Another one, -1/2, right? That's fine, that's a number, times x times y cubed. That's fine as well. Those are all monomials. And notice, even though there is a negative sign, you don't have two things being added or multiplied to each other. So what is not a monomial? If I have x plus 3, this is not a monomial because in between the two things, I have a plus sign. I can only multiply numbers and variables in a monomial, not add or subtract them. Or if I have x squared minus 3x, right? Because of this is not a monomial. So notice this minus, and notice the minus for the -1/2 on top. Do you see how they're different? They have different purposes.
Yeah.
Okay. So that's a monomial. A polynomial is if you have one monomial or a couple of monomials added or subtracted to each other. So for example, x squared is a monomial. But now, if I add to that, or if I subtract from that another monomial, then it becomes a polynomial. So for example, minus 3x, now this is, right, more than one term. Plus 4, this is now a polynomial, okay? So if you look here, each addition or subtraction separates what we call terms. So here, the minus and the plus separate terms from each other. So I have, let's count how many terms I have. The x squared, the 3x, the 4. So I have 3 monomials. They're added or subtracted to become a polynomial. Okay?
So it's a polynomial.
Wait, you were raising your hand. Monomial.
That's one term.
That's one term.
Okay.
One term.
Okay.
Yeah. Mm-hmm.
Does a polynomial have to be 3 or more?
It can be.
Because isn't 2 a binomial?
A polynomial is general. It can have 1, 2, 3, 7, however many. Now, a binomial is the sum of 2 monomials, right? So for example, y cubed plus 2y. Okay? But look, when we say sum, it doesn't always mean that it has to be a plus. So for example, it could also be like x squared minus 4x, right? In the second case, it's a plus -4x, okay? A trinomial is the sum of 3 trinomials. So for example, x squared plus 4x minus 8. All of these, okay, are considered polynomials. It's just that the special case when you have 2 or 3 have special names, okay? So both of these are also considered a polynomial. Okay, now let's talk about the degree of a monomial. This is the sum of the exponents of the variables. So for example, if I have 7y cubed, if I add up all of the exponents for all of the variables, it's 3. Okay? So that's the degree of a monomial. So for example, if I have 5x squared y cubed, what would be the degree? 5. Right? Because it's 3 plus 2. Okay. The degree of a polynomial is the highest degree of each of the monomials. Okay? Yeah.
I'm confused.
Why? Where?
Oh,
yeah. Okay. The degree of a polynomial is the highest degree between each of the terms. So, for example, in the first monomial, what's the degree? 2. In the second one, what's the degree? And in the third one? Okay, the highest one is the degree of the entire polynomial. So we never say what is the highest degree of the polynomial. We only say what is the degree, and it's implied that it's the highest exponent or the sum of the highest exponents. Okay.
Like added and subtracted?
No, because you consider each monomial separately. Okay, so look at this one. 15n to the 4. First, let's see if it's a polynomial, then the degree, then the type. So first of all, is this a polynomial? Yes, it is. Why? Because the exponents are all whole numbers, and that's it. The degree is 4, and it's a monomial because it's one term. Okay, this one is not a polynomial. And the reason is, in a polynomial, you cannot have a variable in the denominator. Okay? So for a polynomial, you can't have x in the denominator. So then these are just like nothing. Okay? It doesn't apply. Here, is this a polynomial? Yes, because all of the exponents are integers, whole numbers. You don't have any variables in the denominator. You don't have any variables in a square root or whatever. So what's the degree of this? 3. And what type is it? Trinomial. Okay. Now, how do we put a polynomial in standard form? A polynomial is in standard form when it's written in order of greatest to least degree. So you start with the term with the highest exponent and gradually go down. So look at the exponents here. I have a 5, 3, 2, and nothing. So like, okay, it's missing a 4. Fine, but that doesn't matter. It's just that whatever exponents it has, it's written in decreasing order. Okay? Does that make sense? Okay. Okay, now, when you have a polynomial, so you're seeing now the degree is the highest exponent, and that term is the most important term. So the leading coefficient is the coefficient of the largest degree term. Okay, in this case, what's the degree? What's the highest exponent? The 5. What's the coefficient of that term? 6. Just the coefficient is 6. So in this case, 6 is the leading coefficient. Okay? All right, so here, write in standard form, identify the leading coefficient. So to write in standard form, I have to start with the highest exponent, which is a 4. So first I do that term. Which one comes next? So plus x cubed, which one comes next? Minus 21x squared, which one comes next? Which one? The x. So do I do what? Plus x times x minus x, what do I do? plus x. Okay, now, this is the leading term. The leading coefficient is 3. Okay? Yeah.
You do the coefficient of the highest.
Correct. Yeah. Okay, so this one, let's write it in standard form. Which one is the first thing we write? Yeah. Okay, but look at the 5. Is it a positive 5 or a negative 5? Okay, so I have to take the negative with it. So negative 5c squared first. Okay, don't forget that. Okay, so 5c squared is definitely the one. Okay, this is definitely the one. But this negative, it belongs to it. So whatever sign, whether it's plus or minus, comes before it, belongs to it. So now the next one is going to be the 3c. But that negative also comes with it. Okay?
But aren't those the two smallest numbers?
And then the next one is the 4, and this one is a positive 4, so that comes with it. Okay?
I'm just confused, but I thought you go from greatest to least.
Correct. So with the exponent, 2 to the 1, 2 to the c to the 2, c to the 1, and then no exponent.
Oh.
Okay?
So even if it's a negative, if the exponent is like
Correct. You don't, yeah, you just look at the exponent.
Then wouldn't it also be 4 to the 1 as well?
No, because this one, if there is no variable, then it's c to the 0.
Oh.
Okay. And also, Jordan, I want you to raise your hand if you have a question. Okay. Okay. So now, what's the leading coefficient here? Negative 5.
Would it be 4?
Okay. Where is the highest exponent? What's the highest exponent?
2.
Correct. So this is the leading term.
I thought it was just...
Yeah. Okay, so this one, what comes first? What am I going to write first here? Yeah, Ellie?
negative 3x to the 4.
Negative 3x to the 4. Okay, Eitan, what am I going to write next? Right, but positive 1/2 x. Okay, there is a plus in front of it. And then finally the plus 7. Okay, so Presley, what's the leading coefficient?
It's negative 3.
Correct. Okay. Now, like terms are monomials. You guys already know this. Are monomials that have identical variables or the combination of variables with the same exponents. Like they're legit identical. Okay. So take a look at this one. 3x squared plus 5x squared. Right? Do you see how the variables are x squared, identical? Those are like terms. We combine them and it becomes 8x squared. Another one would be, for example, 9xy minus 4xy. Right? Look at this one. xy, identical. I combine them and it becomes how many xy? 5xy. Okay, so let's do some matching with like terms. Yeah.
I have a question about the leading coefficient. When you want to write the leading coefficient, should we include the variable?
Never the variable. Just the number, just the constant. Okay, so take a look at this one. I'm adding one thing plus another thing. If there is a plus in the middle, you can just add them as is, right? So here, can you please not lean back? So here, I have 4y plus negative 7y. How many y together? Negative 3y. Plus 5 minus 1 plus 4. Okay? Here. Look at this one. Here there is a negative sign. Never never start subtracting immediately if there is a negative sign. When there is a negative sign, you always need to distribute first. So 4k squared plus 8k plus 2 minus 2k minus 3. Okay? So now 4k squared, which one is a like term with 4k squared? No one. It was a trick question. Who fell for it? Don't fall for them. Okay, 8k, which one is the negative 2k? So here, negative 2k, so that becomes positive 6k. And then 2 minus 3 minus 1. Okay, so it's just building blocks. Just building blocks. Here, I'm going to distribute first. Okay, so let's distribute. Minus 7a squared plus 7a minus 5. Okay. The 5a squared, what's a like term with it?
Nothing.
Negative 7a squared, so correct. Okay. 6a and 7a, so plus 13a. What else? 2 minus 5, negative 3. Okay. Okay, I'll come back to that one. Let's do this next one because I want to move past. Let's do this next one. So for this one has a plus in the middle. So I can just do it right off the bat. So does 4u squared have a like term?
Yeah. 3u squared.
Plus 3, so it's going to be 7u squared. Now, minus 2u minus u, negative 3u, right? Plus 1. Okay, here I have several. So first I'm going to distribute this one. Okay, write it all down. Minus 5f squared plus 1 minus 2f. Even at my age, right now, I write it out first, distribute the negative, then I do the operations. Okay? So then the next one, distribute as well. Negative 2f squared plus 3 minus f. Right? And by rewriting this, right? Who cares? Like, no one's going to say, oh, Miss Malika, she must not know any math because she needs to rewrite it. No, I just want to get it right. So we're going to get it right. Okay? All right. So look at the 6f squared. Does it have a like term?
Yeah. Negative 5f squared and negative 2f.
It has 2. So 6 minus 5 is 3. I'm sorry, is 1. Minus 2 is negative f squared. So minus 7f, what? Minus 2f minus f. How much altogether?
Minus 3f.
Let's try again.
No, you minus 3f together. Negative 10.
Negative 10f. So negative 7, negative 2 is negative 9, negative 1 is negative 10. Is it plus 1? It is plus 1. Okay, so now go ahead and do the next one quickly. Go. Let's see.
Oh, wait, yeah.
Yeah. So first I have 2xy minus 3xy, so that's negative xy. And then 6y, what's it, minus 8y is what, negative 2y. Then let me put a box around the z's. Minus 3z plus 6z, that's 3z. And then 4z. And then what do I have left? 4x plus 3x, 7x. Okay? That's that. Okay? All right. So with that, now you can do homework.